This is a quick look at the Princeton Applied Research 160 boxcar integrator. It's more like a teardown, although I didn't actually test anything while it was working because it's a very difficult instrument to test without the proper signals in there. But I did measure some voltages and took out various cards. Hopefully this is useful to some people. Looks like it's highly modular. I believe the PAR 162 is a more advanced version of this one. It seems easier to use with the controls being more logically placed. But this one actually works quite well. It just takes a little bit more understanding to make it work. Hopefully this is interesting to those who are watching this. So here's the PAR 160 EG&G boxcar integrator. I have taken apart the top and bottom covers, which are very easy to remove. Just a couple of screws and the whole thing slides out. And I'm going to basically do some simple measurements on the power supply voltages. Perhaps I can remove the cards, which you can see on the top. There's a piece of metal that's across all of the cards, which holds them in place, and the power supply is just to the right. Over there you can see the transformer and a few of the caps. It's extremely well built, robust. I'll zoom into some of these parts. I don't really know what these different cards do, and if I open them up, perhaps there might be some markings on them, but I don't expect any text on them, maybe some part numbers, but in any case we'll see how that what that looks like. There are a bunch of power supplies, DC power supplies that are visible on the left side over here. They are clearly marked, so I'll be able to measure those voltages across these filter caps. And then the rest of it are the cards which are plugged into these slots, and all very nicely bundled and connected together. This is the high voltage side over here, the main power cap on this one. This is a 450 volt cap, voltage rating 20 microfarad, and the rest of the analog switches and stuff are on the right side over there. Okay, now we're going to do some measurements on the power supplies. There are 5 power supplies here, DC supplies, low voltage. The first one is a plus 24, the next one is minus 24, the third one is a plus 4.5, there's a plus 12 and a minus 12. So connected ground, which is common to all the supplies from what I can see. So if I measure the main power supply pins, that should give you a reading. So this is 24 volts, and it's reading 24.018. Second one is a minus 24 volt, it's reading minus 24.008. Third one is a 4.8 volts, reading 4.5 volt supply is reading 4.816, off a little bit. This is the plus 12 volt supply, 12.015, and the minus 12 reads minus 12.000. Excellent. So these supplies are, except for the 4.5, very much on target, so nothing to worry there. The high voltage cap on the main of the transformer is here. That's 288.5 volts, lethal voltage there. Don't want to touch that. Now back on the top side, I'm going to remove these cards and take a look at them. So the first thing is to remove this plate over here. Remove the power supply cord. So that comes off nicely. So the first card on the Far side is this one, probably, not sure if I can. There it is. Looks like a power supply card. As you can see, there's a plus 24 volt adjustment, and since everything looks good, I'm not going to touch this card. A bunch of fuses. I think this may be the main power supply board, which for the fuse for all the different supplies. Very beautifully done in terms of the PC board design for this one. Just seeing double layer board, looks like silver. I'm going to put this back and then take the next card out. So this was an easy one to figure out, I think. It's a bit doesn't go in that easily, so I have to line it up cleanly. Okay, snap it back in place. Next card is this one. It looks like an R signal card. As you can see, beautiful ground plane. It's not a solid ground plane, but you use some pattern there. And this looks like some kind of a signal, a diode, a photodiode and a transmitter kind of deal. Do some chopping perhaps, I'm not sure. Again, very beautifully done. All discrete components in here. Okay, back in place. The third card. Similar. Of course, if I knew these what these numbers meant, I could probably figure out what these cards are if I had a manual, but it's no manual for this. Again, nothing, no information here. Okay, it looks like a gating control, so this must be one of those tuning for the ramp or something like that, sampling. So there's a potentiometer for the controlling the gating, min and max. Somebody's marked this one over down here, not sure what that was for. Check this one later. Okay, here is some more information, some HR overload, gain, HR gain, and somebody seems to have marked some components then down there. There's some bit of corrosion on this one, and these are the parts that are tunable, as you can see. Again, silver traces, extremely robust connectors down there. Some of these are pretty stiff to come out, so don't want to damage them. any component while pulling them out. This one's really hard. Try the next one. Okay, this one's a bit easier. Okay, I see something here. The SIM AT cal is the scan 0, so this must be the scanning function card that does the sweeps. Oh, there's one IC down there, SN72709, probably a digital chip there. I'll look that up. Second to last card, couple of digital chips, as I can see again, logic, I think. 74H1 H400, I think that's probably a NAND gate or something. These are all digital mostly. There's one potentiometer on top. Not much information here. A1 and A2, so those are the two digital chips. The last one, even less information here. Another IC. A bunch of diodes and a few transistors. Not much to go by. Yeah, if I knew what these numbers meant and service manual, probably easy to tell. So that's all the cards in there, except for one card which I couldn't get out easily. The others seem to be fairly well placed. I'm going to try and get this other card back in and then come back. There's one more card in the front over here which I neglected earlier. So this is that one, which is let's see, any markings that are useful. Scan calibration. The balance and a few capacitors have been named, which are tunable, I guess, these. And I think somebody has figured out what these transistors are, I guess, and marked them. Those are off. Again, very clean, full ground plane. Now get a brief look at the back of the front of the panel. You can see there are some large switches and so on. There's a large 10K potentiometer for the scan. I'm sorry, the scan, not the scan, the timing for the gating. And there's other caps in up there, the yellow ones. I think those could be power supply related again. Not much to go by. The meter is right up there and on top. And the main power supply, transformer and high voltage DC caps, transistors for the regulators. Fairly standard, very well heat sinked, extremely tough build. And at the back there are some connectors that let's look at that over here. We have the outputs for normal inverted, the recorder outputs, and then there's the external gating input, is in and out for that, a scan delay which can, I think, can be an input, and there's also an output which you can send to instrument like a scope, the time base external input, and also an output below that, and there's a preamp output which probably is the output from the main of the first stage. So it's a very well built instrument. It weighs about 35 to 40 pounds, 17 kilograms, so it's heavy and built like a tank. I'm going to put this board back, and then I will fire it up again to make sure it works. I haven't caused any problems in seating the boards. Okay, it's back on now, and the light is on. I checked the voltages after the reinstallation of the cards. Looks to be good. Of course, it's very difficult to test anything without any real signals or a proper setup. I'll probably do that next and check it to make sure everything's back to what it should be. As you can see, this instrument is a work of art. Hopefully you found something useful in this, although I couldn't really give you much detail about what these various cards did, but somebody who's probably more familiar with this could probably comment. Anyway, thanks for watching. See you next time.